Hi students, I'm back to talk to you about measuring volume, and in this first video I'm going to talk about specifically measuring the volume of a liquid, and there will be a second video about measuring the volume of a solid. So when we talk about volume, we're talking about how much space something takes up. So when we measured length, we were talking about one dimension, right? We weren't measuring in both directions, we were only measuring one thing at a time. And when we measure mass, that's just the weight of it. But when we measure volume, we're looking at a three-dimensional space, right? We want to know how much how much space it takes up going this way, and how much it takes up going this way, and how much it takes going this way. So we need to talk about the whole shape of the object and how much space it takes up. So liquids are pretty easy to do that, because when we pour a liquid into a container, it fills from the bottom up, and we can just read a scale that's on the side of the container. That's what we do with beakers and graduated cylinders. So that's where I'm going to start. You can also measure volume with things that you have at home. You probably have measuring cups that you use when you bake, so you can measure liquids that way as well. But in science, we use these tools. So I want to talk just for a minute about the graduated cylinder and the beaker. So this one measures up to 500 milliliters. And remember, I've been telling you that the tool always tells you what units are being measured in, and this is no different. It tells you that it measures in milliliters, and it goes to 500. It has all these lines on it, so there's actually 10 lines between 500 and 450. So 10 lines to cover 50 milliliters. That means every line represents 5 milliliters. All right, so let's take a look at this one. This is a beaker, and it also measures up to 500 milliliters, and it tells you milliliters right on it. And if we look at the numbers here, we'll look at this side. Starts with 100 at the bottom, then 200, 300, 400, 500. And how many lines are there between 100 and 200? There's only one line there. So that one line represents how many milliliters? Represents 50. So this container is usable for measuring, but not if you want to be very accurate. If you were trying to measure 235 milliliters, you'd have a hard time estimating where that is between 200 and the middle line between 200 and 300. But if you were going to measure 235 milliliters on this one, you could find the line that actually represents it. This line between 200 and 250, the middle line there, represents 225. And if each of the lines beyond it goes by 5, the next line would be 230 and then 235. So you know exactly how to measure 235 milliliters in this instrument. So if you're trying to be precise, this is the one you use. If your instructions say, go get about 200 milliliters of water, if we say about 200 milliliters, accuracy must not be important. And so then it's perfectly fine to go use a beaker to do it. Okay, so I'm going to set this one aside. This one I brought out to show you because it's got very nice colorful letters on it, but this is really too big for our ordinary uses. And actually, 5 milliliters between the lines is not super exact. We can get much more exact if we use a different graduated cylinder that's made for more accurate readings. So this one I didn't show you at first because it's kind of hard to see the markings on it. I actually had to put a marker to it and a paper inside so that you can read what it says. But this is the tool we'll use most often when we're measuring volume of a liquid. Still a graduated cylinder, it just has more increments on it, so it's more accurate. Okay. One thing I want to talk to you about water when you're measuring volume of liquids is that water it's cohesive. It likes itself. So it's attracted to itself, and it can also be attracted to the container that it's in. And that property of water causes there to be a bend in the top of the water. And I've drawn that for you in this picture. So I've drawn a picture of a graduated cylinder, and the green line represents the water in the graduated cylinder. And if you look close, you can see that the green line is kind of curved. You may have noticed this if you looked at water in a container before, and that's because the molecules of water are actually attracted to the container, and so they cling to the sides of the container, and they cause it to have that curve. So when you're measuring, you want to look for that, and it actually kind of looks like, it's a little hard to describe. I've drawn it as a curve, but it actually kind of looks like two lines. And what you're seeing is the line behind, because water's clear, you know. You're seeing the line behind, and you're seeing the curve up in the front. So you actually kind of see two lines like that. So you want to make sure when you are measuring that you're measuring at the meniscus. And that's where the water is curving, the lowest point where it's curving. So you're looking through the water, through the graduated cylinder, and trying to find the line that lines up with the bottom of the meniscus. That's how you spell meniscus, right there. Okay. And by the way, when you measure with a graduated cylinder, when you measure anything where you have to actually eyeball where the end of the thing you're measuring is, you need to get your eye right on level with it. So let me show you what I mean. So I have my graduated cylinder here, and let's say I want to see how much liquid is in it. Let's see, this goes up to 100 milliliters. So I can't pour this whole thing in because I have more than 100 milliliters in it, if you see. More than 150, actually. More than 150 milliliters. So I'm just going to pour some in. Okay. So if I wanted to see how much liquid was in here, remember I'm looking for the curve at the bottom, so I have to be careful and look for it. But I never want to try and calculate and determine its measurement while I'm looking down at it. I'm not going to get an accurate measurement that way. I absolutely have to be level with it. And it's not proper to lift it up, because if you tip it, you're going to change the measurement. So put it on a flat surface, get up out of your seat, and get down so you can see it from eye level. So I want my eyes to be level with this. Maybe it's going to help me to take my glasses off, I think. All right, so I'm looking for the bottom curve of the liquid, and I see that it's between 70 and 80, but I have to look at the markings between 70 and 80 to see how much each line represents. So I have 10 lines between 70 and 80. So what does that tell me? Each line represents 1 milliliter, right? So I can count the lines from 70 up to the top of my water. So it's 71, 72, 73, 74, 75, 76, 77, 78. So this is holding 78 milliliters of water. Let's say for my experiment, I needed 80 milliliters of water, and I'm at 78. So I need to add more. So I could just pour some water in, but how lucky do you think I'd have to be to get exactly 2 extra milliliters in here to reach the 80? It'd be hard just pouring it from this. So that's why in science we use something called a pipette, little like an eyedropper thing. And I can add smaller amounts of water so I can get to the 80 mark without overshooting it and having to dump water out. Because then you get into the back and forth where you're dumping water out and then adding water back, and it's too much. So you dump some out, and now you've taken away too much. So we don't mess with that. Use the pipette, and you can be super accurate. So I'm going to draw up some water into my pipette. I'm going to stay down here so I can watch when I get to the right amount of water in there. And I'm going to add it a few drops at a time until my water rises to 80. And it's always good to stop and let the water settle, because when you add water to it, it starts rippling. And then you can see if you need a little more, you can add it. And by the way, if you get too much in here, it'll only be a little too much. So you can use this to get out a little bit of the liquid that if you went over too much. All right. So important to know, use the right tool. You need to figure out what each of the lines mean because it's not the same on every graduated cylinder. Remember this big one over here. Every line represented 5 milliliters. And in our beaker, every line represented 50. So you can't just pick up a graduated cylinder and just count the lines and decide every one is 1. You have to look at it and see how many lines there are between the biggest numbers and then figure it out. So remember, if you don't know how to do that, you ask. You ask. Don't fudge it. Don't wing it. Don't pretend you know what you're doing. This is the time where we nail this down so we know exactly how to be good at measuring. Okay? Come back in the next video and I'll show you how to measure the volume of a solid.